All right, let's talk about something that, if you're a maintenance manager, you know all too well. Your parts cleaning system. It can be the unsung hero of your whole operation, or, let's be honest, the hidden villain. So today we're going to cut through all the noise and give you a really clear, practical guide for picking the right equipment, something that's actually going to boost your efficiency without wrecking your budget. Okay, let's dive in.
So let me just ask you this straight up. That system you've got right now, is it costing you more than you think? It's a simple question, right? But the answer is usually way more complicated. That good enough system that's been chugging along for years might be quietly draining your budget through wasted materials, extra labor, and just endless regulatory headaches. It's easy to get comfortable, but you have to ask, is it still the smartest way to do things?
And here is exactly why that question is so important. For anybody out there still using those traditional open-top vapor degreasers, this should be a huge wake-up call. Up to 60% of your expensive solvent could be literally vanishing into thin air. Just poof, gone. That's not just a little inefficiency, that is a major financial leak in your operation. And this image, well, it really shows how far we've come. We've moved way beyond simple dunk tanks into these really sophisticated, controlled processes. The whole landscape has changed because of demands for higher quality, much stricter environmental rules, and, of course, economic pressures. Bottom line, what worked yesterday might not even be competitive tomorrow. So, to help you navigate all this, here's our game plan. We're going to start with why you should even think about a change in the first place. Then we'll walk through a 4-step process, auditing your real needs, understanding your options, comparing the tech head-to-head, and then finally, picking the right solution. By the end, you're going to have a solid playbook for your next big decision. So let's start with that big question. Why fix what isn't broken? Well, the truth is that good enough system often comes with some pretty serious hidden costs. We're talking everything from wasted solvent to the ever-growing headache of regulatory compliance. This quote from our source material just hits the nail on the head. It's a challenge, really. It's saying, go do the math. Put a real dollar amount on all that solvent that's just evaporating. Once you see that number, suddenly investing in a more efficient, contained system starts to look like a no-brainer. It's a simple exercise that can build a powerful case for an upgrade. And, it's not just about the wasted material. You're looking at this complex web of regulations, this alphabet soup of agencies. You've got RCRA for hazardous waste, the Clean Air Act limiting your emissions. Staying on top of all this means endless reporting. It impacts worker safety, and it can create huge long-term liability for your company. A new system might not just clean better. It might drastically reduce your entire compliance workload. Okay, so you're convinced a change might be in order. The very first step isn't to start flipping through equipment catalogs. It's to look inward at your own process. You have to define precisely what you need. And the key here is to avoid over-cleaning, which is a waste of time and money, or, even worse, under-cleaning, which causes quality nightmares down the line. Here's a great 6-step guide from the source to get you there. First, are you even sure you need this cleaning step? Seriously, question everything. Then, define exactly how clean a part needs to be, your standard. After that, really understand the gunk you're fighting. From there, you can check out a few technologies, and, this is critical, test them with your own parts. Don't buy anything until you do. Finally, you pull the trigger on the most cost-effective solution. Once you know exactly what you need, it's time to explore the how. Now, the world of industrial cleaning can seem kind of overwhelming, but honestly, it really just boils down to 2 fundamental approaches, 2 different philosophies for getting the job done. And this illustrates it perfectly. On one side, you have mechanical force. Think of this as the brute force method. It's all about using friction and impact, like abrasive blasting, to physically knock the soil right off the surface. On the other side, you have chemical action. This is the finesse approach. It's about using solvents or water-based solutions to dissolve the contaminants, breaking them down on a molecular level. Okay, now we get to the core of it. You know what you need, you know the 2 main camps, so let's put them head-to-head. We're going to compare them on the things that actually matter in a busy facility, how well they work, the waste they create, and what materials they play nicely with. So at a high level, the choice really depends on the soil you're dealing with. Mechanical abrasive methods, they are fantastic for heavy-duty jobs like blasting off rust, scale, and old paint. But they create a second mess you have to clean up, all that spent media, and you can damage the part if you're not careful. Chemical solvents, on the other hand, are the champs for oils, greases, and adhesives. The catch? you're often dealing with hazardous waste and those pesky VOC emissions. So let's drill down into a really common scenario, cleaning high-precision parts. This is where the trade-offs get crystal clear. Abrasive blasting might just be too aggressive. You could risk changing the dimensions of the part or embedding media into it. But aqueous cleaning, especially when you pair it with ultrasonics, can gently get into all those complex shapes and blind holes, making it a much safer bet for delicate components. Look, this is so important. The best cleaning method in the world is useless if it destroys the part you're trying to clean. This table right here, this is your critical gut check. A strong alkaline solution might be perfect for your steel parts, but it could severely etch your aluminum ones. And a solvent like acetone, forget it. It will literally dissolve certain plastics like ABS. You have to match the method not just to the gunk, but to the part itself. Okay, you've done your homework. You've narrowed down the right technology for your parts. Now comes the final make or break step. Choosing the specific equipment and, just as important, the vendor who's going to support it. This is all about making a smart purchase that's going to pay off for years to come. When you talk to vendors, don't just ask for the price. You are interviewing them for a long-term partnership. You need to ask about maintenance, about support contracts, about training for your team. You have to understand all the consumables you're going to need and the waste it's going to produce. And honestly, the single most important question on this list is the last one. Can we test it here with our actual parts? A good vendor will always say yes. And this brings us to what might be the most important number in this entire process, the total cost of ownership, or TCO. Look, the sticker price is just the down payment. The TCO is the real, all-in cost of that machine over its entire life in your facility. Focusing on this number is what separates a good purchase from a truly great one. And TCO isn't some fuzzy, abstract idea. It's just the sum of these very real costs. You have the initial price, of course, but then you have to add the cost of all the consumables, the energy bill, the waste disposal fees, labor, and maintenance. And here's the kicker. For a lot of systems, things like consumables and waste disposal can easily end up being more than half of the total cost, completely dwarfing the initial price tag in just a few years. A cheaper machine today could have a much higher TCO tomorrow. So we have covered a ton of ground here, right? From the big picture philosophy of cleaning all the way down to the nitty-gritty of calculating costs. Now, let's just pull it all together into a simple, repeatable strategy you can use for any future equipment decision. Here it is, your 4-step playbook. Simple. First, audit your own needs. Figure out your clean enough standard. Second, know your basic options. Is it going to be mechanical force or chemical action? Third, compare the actual technologies, paying super close attention to material compatibility. And finally, select your solution based on the total cost of ownership and, of course, a successful real-world test. So, as we wrap this up, this is the thought I want to leave you with. Your next cleaning system, it isn't just another piece of equipment you're buying. It's a strategic investment in your facility's efficiency, its safety, and its quality. The real question you're answering is the one on your screen right now. What will your choice say about your operation's future?